So students, today in this video we are going to see that how we can measure the pressure using manometers with some examples. In our previous video we have seen that what are the different kind of manometers that are used to measure the pressure of a fluid. So starting with the first manometer, which is piezometer, you can see the arrangement that here there is a section of a pipe which is connected with a glass tube, and here you can see two arrangements. So in both the arrangements the pressure that will be obtained at the point A of a fluid in the pipe will be same. So here this is a cross section of a pipe in which the fluid water is present and whose specific gravity is 1. So with the specific gravity value 1, we can find the pressure at the center of the pipe A using the equation P is equals to rho G H. So the pressure at the center of the pipe will be rho into G into H, and this rho will be specific gravity into 1000 into 9.81 into H. So that is 1 into 1000 into 9.81, and suppose the height of this water column is 1 meter. Okay, so in place of H I will write 1. So my value will be 9810 Newton per meter square or 0.981 Newton per centimeter square. So this will be the value of pressure that will be obtained at the center of the pipe A. So now starting with the second kind of manometer, which is U-tube manometer. Here in this kind of manometer, as you can see, again a cross section of pipe is provided and in that pipe the fluid oil is present with a specific gravity of 0.9, and the other end of this U-tube manometer is open to atmosphere. Okay, and the height H1 is 8 centimeter, height H2 is 20 centimeter, which are the heights of the left limb and the right limb of this U-tube above a datum XX, and the another fluid which is filled in this U-tube is mercury, whose specific gravity is 13.6. So if I will consider this as a datum, then this will be right limb and this will be left limb. So now suppose I want to find the pressure of a fluid which is oil in a pipe at point A. So how I can solve it? So I will first of all find the pressures about the datum XX in the left limb and right limb, and then I will compare both the pressures to get the value of pressure at point A. So let us start with the numerical. First of all I will write that pressure above datum XX in left limb will be, so this is my left limb about the datum XX. So here the above the datum there is only one fluid which is oil, and I can, for that I can write the equation rho 1 G H1 plus pressure at point A. So what is rho 1? That is the density of fluid in the left limb, and in the left limb which fluid is present? Oil is present. So for density of oil I will write specific gravity into 1000, that is 0.9 into 1000 into 9.81 into H1 is 8 centimeters, so 0.08 meter plus PA. Okay. Similarly, pressure above datum XX in right limb will be, now above the datum XX in the right limb of U-tube manometer there is again only one fluid up to height H2 which is mercury. So rho 2 G H2. So the value of it will be, rho 2 will be 13.6 into 1000 into 9.81 into H2 is how much? 20 centimeters. So 0.20 meter. Okay. So now comparing the equations 1 and 2, what we will get? We will get with the answer of PA plus 900 into 9.81 into 0.08 minus 13 equals to 1360 into 9.81 into 0.20. Therefore, here the value of PA that I will get will be 26977 Newton per meter square or 2.697 Newton per centimeter square. So, solving this, we will get the value of pressure at point A in a pipe as 2.697 Newton per centimeter square. So, here in the third case, we are going to find the pressure at point A using differential U-tube manometer, where following details are given. Okay. Here two pipes are given. In pipe A, oil of specific gravity 0.9 is there. In pipe B, water of specific gravity 1 is given, and both these pipes are connected with a U-tube manometer in which mercury with a specific gravity of 13.6 is filled. Also, the values of H1, H2 and H3 are given, and the pressure at point B, that is at the center of pipe B, is also given, which is 9.81 Newton per centimeter square. So, using all this data, we need to find the pressure at point A. Now, here again a datum XX is given. So, writing that pressure above datum XX in left limb will be given as, this is right limb and this is left limb. Okay. So, now we need to solve the pressure about datum XX in left limb first. So, if we talk about the left limb, then we have two fluids in the left limb about datum XX. So, starting with here, that pressure at point A will be PA plus, now if you can see that up to height H1, the liquid which is filled is oil. So, we will write rho 1 G H1 plus, and up to height H2 to the datum XX, the liquid which is filled is mercury. So, we will write rho 2 G H2. Okay. So, PA plus 0.9 into 100 into 9.81 into H1 is 20 centimeter, so it will be 0.2 meter plus 13.6 into 100 into 9.81 into H2 is how much, 10 centimeter, so it will be 0.1. So, this will be pressure above the datum XX in left limb. Now, solving pressure above the datum XX in right limb, what we will get? Okay, so here again starting about the datum XX in right limb, starting over here. So, pressure at B plus, now if you can look, then above the datum XX only one fluid is present, only one liquid is present, which is water. So, we will write rho 3 G H3. So, it will be PB plus rho 3. So, the density of water will be 1 into 1000, sorry, here it is 1000, here it is also 1000. So, 1 into 1000 into 9.81 into height of column H3 is 60 centimeter, which is 0.6 meter, and for the value of PB, I can write it as 9.81 into 10 raised to 4 Newton per meter square, because the value which is given is in centimeter, Newton per meter square. Okay. So, solving equation 1 and 2, the value of PA will be 8.887 Newton per centimeter square.